discuss about the electromagnetic waves and matter, and I am also considering propagation and a linear media. Suppose we have a media and there is no free charge and free current density and a matter, then Maxwell equation must be, because the Maxwell equation del dot D, this is actually equal to rho divided by epsilon naught, and there is no charge density, then this is equal to 0. The divergence of B is equal to 0. Curl of E, which is equal to minus partial B divided by partial T, and curl of H, which is equal to partial D divided by partial T. So these are the Maxwell's equation when no free charge and no free current. As we have considered the medium as a linear, then we can say that the displacement current is equal to epsilon E, and the auxiliary H, which is equal to 1 over mu into B. Now, if epsilon and mu do not vary from point to point, then the Maxwell equation reduces to, if we put the value of D, epsilon E, in this equation, then we can write down divergence of E, which is equal to 0. And this is equal to the same divergence of B, which is equal to 0, and this also remains the same. And the fourth equation, if we put the value of H here, the value of D here, then we must have the relation curl of B, which is equal to mu epsilon partial E divided by partial T. These four equations remains the same when we are considering the Maxwell equation for a free space, only where in free space we have mu naught epsilon naught, but here we have mu and epsilon, this for a material that we are considering. So I have written the Maxwell equation in free space, and in matter one can see that the difference is only mu epsilon. In free space we have in free space we can replace mu by mu naught and epsilon by epsilon naught. Then this will be for the free space. Here, the electromagnetic wave is propagating through a linear homogeneous medium at a speed. We know that the relation for a free space, C, which is equal to 1 over mu naught epsilon naught under root. This is the speed of light. And when a light is moving with velocity v in a medium, then we must replace mu naught and epsilon naught by mu and epsilon naught. This mu and this epsilon is the permeability and permittivity of that material. And this is further equal to C divided by N, where N is the refractive index. Then we can write V, which is equal to C divided by N, or N is equal to C divided by V. And further we know C, which is equal to 1 over mu naught epsilon under root, and V, which is equal to 1 over mu epsilon under root. If we put the values here, this is the value of C, this is the value of V, and a material, then by after some simplification, we can write down mu epsilon divided by mu naught epsilon under root. And for most material, the mu and mu naught is approximately equal. Then we can say that this and this will cancel out, and we have epsilon divided by epsilon under root, and this is equal to epsilon. This is the relative permittivity. This is the relative permittivity. Okay, from our previous knowledge, we know if we replace epsilon by epsilon, mu naught by mu, and epsilon by v, then the energy density and matter will be equal to half epsilon E square plus 1 over mu B square. Because for a free space, this energy density we have calculated already, and this was 1 over 2 epsilon naught E square plus 1 over mu naught B square. This is the energy density for a free space, and this is the energy density for a material, for a matter, because only we replace epsilon by epsilon and mu naught by mu. Similarly, the Poynting vector for a free space, which is equal to 1 over mu naught and E cross B. If we replace mu naught by mu, then this is the Poynting vector in a matter. And similarly, the intensity for a matter will be equal to 1 over 1 over 2 epsilon V E naught square. And for a free space, this energy, this intensity is equal to half epsilon naught V E naught square. So just we replace epsilon naught by epsilon. So this will be the intensity for a matter. I think this will be enough.